If you're a class 10 student and you still don't know the difference between metal and metalloids, this is the video that you should be watching to understand the differences between metal, non-metal, and metalloids. What are metals, non-metals, and metalloids? So metals, non-metals, and metalloids are part of the periodic table. They are the three elements that are necessary, okay? So now this is the periodic table you can see over here. Now in the periodic table, you can see that the left hand side are the metals, the right side are the upper right side are the non-metals, and the zigzag line over here which I'm indicating is known as what? Metalloids. Right, now let's go and move on to the differences. Okay, so let's get going with the first thing, which is appearance. Now metals are shiny and lustrous, with examples for it are gold and silver, and non-metals are dull except for iodine, and at some point metalloids are shiny, but some of them are not, like silicon. Let's get going with the second point, which is state at the room temperature. Now mostly metals are solid at room temperature except for mercury, and non-metals can be either solid, liquid, or gas at any point. But the metalloids over here are always solid, just like metals. Okay, now the third point over here is hardness. Now for metals, I would say that it's strong and hard. Okay, and for non-metals, I would say that it's brittle. Brittle, the meaning of brittle is that it is easily broken. Okay, that means when bended or hammered, it can be easily broken. Okay, and same goes with metalloids. It's also brittle. It easily breaks. Okay. So now the next one, the fourth point, which is malleability. Okay, like malleability means when the element can be turned into sheet-like objects. Okay, for instance, like when we hammer metals, they can be turned into thin sheets. Okay, but for non-metals, that's not the case. Okay, it's not malleable. As well as metalloids, that's not the case. They cannot be turned into thin sheets. So the fifth point over here is ductile. Can it be turned into thin wires? For metals, yes. For non-metals, no. And for metalloids, not at all. So now let's go on with the sixth point, which is sonority. It means a ringing sound. Have you ever seen a bell which is rang? Okay, so there's a ringing sound over there. So like yeah, all metals create it, non-metals don't create it, and metalloids don't also create it. So yeah. Now the seventh point over here is conductivity. Now we all know that metals are good conductors of electricity and heat, okay? But non-metals are poor conductors except for graphite. That we'll talk about some other day. But right now let's go on with this. And now metalloids, they're semiconductors. You know that there's always this one kid who's good at both, like studies and sports, right? So that way, metalloids is that, okay? Now let's move on to the next point, which is electron behavior. Now over here, we would know that metals lose electrons. Okay, and metals lose electron, and that is why they are positively charged. Now they are positively charged. That means they are called cations, and because they are called cations, the example for this would be what? Na plus. Now for non-metals, we would understand that they gain electrons, and because of the gaining of electrons, they become anion, negatively charged ions. Okay, and the example for this would be Cl minus. Whereas for metalloids, you can know that they are either electron gaining or either losing electrons, so they can be both in both ways. So like yeah, if you want me to make more videos on these topics of chemistry, physics, and biology, let me know in the comment section, and please share, save, and follow me for more videos. Thank you.